Welcome to vpod.ai.
Glad to be here.
Now, this deep dive is sponsored by StoneFly. They're your trusted solution provider and advisor for, well, a whole range of things. Enterprise storage, backup disaster recovery.
Hyperconverged VMware, Hyper-V, Proxmox clusters, AI servers.
Right. And also the SA365 turnkey security appliance, plus public and private cloud solutions. You can find out more at stonefly.com.
Definitely worth checking out.
So today we're diving into something really fascinating, construction technology, but not for down here on Earth, initially anyway. We're talking about building on the moon and Mars.
Exactly. It sounds like sci-fi, but it's a very real area of development. The whole point is enabling humans to actually stay on other planets long term.
And to do that, you need infrastructure, right?
You absolutely do. You need habitats, obviously, places to live, but also things like radiation shielding, roads, even landing pads for the rockets.
You can't just keep shipping everything from Earth. It's just not sustainable.
Precisely. So the key is using local resources. That's what In-Situ Resource Utilization, or ISRU, is all about. And NASA's Space Technology Mission Directorate, they're really pushing this.
Through different programs and working with private companies, too, I gather.
Yeah, lots of collaboration. And what's really cool, I think, is how this space-focused tech is already starting to trickle down and have an impact back here.
Okay, let's get into that. Where should we start? Maybe with that NASA project, the MMPACT one.
Good place to start. MMPACT stands for Moon to Mars Planetary Autonomous Construction Technology. Bit of a mouthful.
Oh, yeah, just a bit.
It's funded under NASA's Game-Changing Development Program, managed out of Marshall Space Flight Center. And the core idea is large-scale robotic 3D printing.
For building things on the moon and Mars, using robots?
Autonomously, yeah.
Yeah.
That's the goal. They've already done initial tests using fake moon and Mars dust regolith simulants, they call them.
And how did those go?
Pretty promising, actually. It shows the potential. A big part of the project, though, is figuring out how to process the real stuff when we get there. And, crucially, how to extract binders.
Binders? What are those, like the glue?
Sort of, yeah. Things like water, potentially, that you could get from the regolith itself. If you can do that, you don't need to launch nearly as much mass from Earth.
Ah, okay. So the regolith is the main ingredient, the aggregate, and you just need to find the cement locally.
That's the idea. Makes the whole concept of building large structures way more feasible. And NASA's been looking into using local materials for a long, long time. People like Dr. Kushnevis were doing early work on this.
Right, Dr. Kushnevis. Contour crafting, that rings a bell. That's related, isn't it?
Very related. Contour crafting was developed under the NASA Innovative Advanced Concepts Program, NIA. It's another large-scale 3D printing approach specifically for, off-world construction.
How does that one work? Is it similar?
It involves extruding molten regolith mixed with a binding agent. Think of a giant robotic nozzle building things up layer by layer.
Molten regolith. So you're melting moon rock.
Essentially, yes. And using that to build big, solid structures. Things like radiation shielding, which is absolutely vital for protecting crews.
Or those landing pads you mentioned earlier.
Exactly. Imagine being able to just print a landing pad when you arrive.
Oh.
Autonomously. That's a huge capability. Especially for something like radiation shielding. It fundamentally changes how we can plan for long stays.
Definitely a game changer. Now, didn't Dr. Kushnevis also develop another method? Selective. Separation sintering.
He did, yes. SSS. Also supported by NIAC. This one's a bit different. It uses heat and pressure on layers of powder.
Powder, like metal powder.
Could be metal, could be ceramic, even composites. You basically fuse the powder together layer by layer to create the object. It's good for smaller, more precise things.
Okay, so contour crafting for the big stuff, the habitats and pads, and SSS for, say, tools or replacement parts.
That's a good way to think about it. SSS is quite energy efficient too, which is a big plus for working on the moon or Mars. And you could potentially use it even in microgravity, like on a space station, making interlocking tiles, spare parts, that kind of thing.
It's pretty incredible tailoring these manufacturing methods for space. But you mentioned earlier these things are having an impact back on Earth.
Absolutely. And this is fascinating. Dr. Kushnevis actually founded a company, Contour Crafting Corporation. Their goal: to use these same 3D printing techniques, developed with NASA funding, for housing and infrastructure right here.
Wow. So printing houses?
Yeah. Think about disaster relief housing or affordable construction in developing areas. It can be much faster and cheaper than traditional methods. It's a direct tech transfer.
That's a fantastic example. Any others?
Definitely. There's a company in Austin, Texas called Icon. They're also a NASA partner, and they were already 3D printing homes on Earth. They combine robotics, software, advanced materials.
So the push to build on Mars is directly leading to innovation in home building here.
It seems so. And ICON is deeply involved with NASA's Mars simulation efforts, too. NASA built a simulated Martian habitat at Johnson Space Center.
Oh yeah, I heard about that. The 3D printed Mars
That's
house.
the one. It's about 1,700 square feet. And it's being used for the Capita mission's Crew Health and Performance Exploration analog.
Analog missions. So people live in it like they're on Mars.
Exactly. Four-person crews are doing year-long simulated missions inside this habitat, testing everything, understanding the challenges. The first crew started in summer 2023, and they've got sims planned through 2026.
A whole year pretending to be on Mars inside a 3D printed structure. What's it called?
Mars Dune Alpha.
Mhm.
It's got crew quarters, workspaces, common areas, everything they'd need.
And Icon built this.
They did. They were part of NASA's 3D printed habitat challenge earlier, which really pushed the tech forward.
Okay.
Then in 2021, they used their system to actually build Mars Dune Alpha.
So from a NASA challenge straight to building a critical simulation habitat.
Pretty direct path, yeah. And ICON's still working with NASA through the Small Business Innovation Research Program, developing something called the Olympus Construction System.
Olympus. Let me guess. Designed to use local Moon and Mars resources.
You got it. It all comes back to ISRU, using what's there.
And don't they use lasers somehow? I feel like I read that.
You're right. ICON uses a technique called laser vitreous multi-material transformation. Basically, high-powered lasers melt the regolith.
Melt the moon dust again.
Right. And it then solidifies into these really strong ceramic-like structures. It's like turning the local dirt directly into building blocks using focused energy.
Sounds incredibly futuristic, turning dust into buildings with lasers.
It does, doesn't it? But it could create infrastructure that's really resistant to all the nasty stuff up there, the abrasive dust, the radiation, the wild temperature swings.
Building things that last, not just building them. Makes sense. Wasn't there also an experiment on a Blue Origin rocket with
Yeah.
fake moon dust?
Project Dune Flow. Yeah, that was ICON too. They wanted to understand how simulated lunar regolith behaves in actual lunar gravity, or close to it.
How'd they manage that?
They flew their experiment on a Blue Origin suborbital rocket back in February 2025. It was part of NASA's Flight Opportunities Program.
And it worked. They got lunar gravity.
For about 2 minutes during the flight, yeah.
Yeah.
Enough time to see how the simulant behaved compared to, the real Apollo samples. That data is super important for designing construction systems that will actually work on the moon.
Wow. From lab tests to rocket flights. They're really testing this stuff thoroughly.
They have to. But it shows this isn't just theoretical anymore. It's active research, active development, and like we said, it's already spinning off technologies we can use down here.
It really does blur the lines. Seeing companies use Mars-inspired tech to build houses today, it makes the whole idea of using local resources on other planets feel much more achievable, like a critical step towards actually staying out there.
Absolutely. Which kind of makes you wonder, doesn't it? How else might these technologies, born from the extreme challenges of space, change how we build things right here on Earth in the future? The possibilities are pretty mind-bending when you think about it.
Definitely something to chew on. And speaking of essential foundations for progress, both here and out there, we want to remind you again about our sponsor, StoneFly. They provide those robust, secure data storage solutions that are critical for this kind of innovation.
That includes enterprise storage, backup DR, security appliances, the works. And they actually have a pretty compelling offer right now. A 100 terabyte immutable and air-gapped SSO NAS.
Immutable and air-gapped. That means really secure, right?
Extremely. Protects your critical data. And that 100 TB system is available for just $8,995.
That's a serious amount of secure storage. You can find out more about that offer and all of StoneFly's solutions at stonefly.com.
Check them out.
Well, that brings us to the end of this deep dive. It's been fascinating exploring how we might actually build our future homes among the stars, and how that effort is already shaping things closer to home.
Truly incredible stuff.
Thanks for joining us, and we hope we've sparked your curiosity about what lies ahead.